Hello guys, in this video we will be learning how to calculate the area of a triangle. It's a pretty straightforward topic. You just have to memorize a few formulas and apply it. The formula that everyone knows is half into base into height. This is a pretty straightforward formula given that the side and the corresponding altitude is provided to you. If we take this as the base of the triangle, let me just mark it here. So if we take this as the base, we need the altitude that is perpendicular to this base. Only then can the area be calculated as half into base into height. What if we consider this as the base of the triangle? Again, to calculate the area, we need to have the height that is perpendicular to this base. Now we can say that the three bases of the triangle will have three corresponding heights, and the areas calculated using these three pairs will obviously be the same. So if B1 H1, B2 H2, B3 H3 are the three pairs, we see here that B1 H1 is equal to B2 H2 is equal to B3 H3. What conclusion can you come to regarding the relationship between B and H? X1 Y1 is equal to X2 Y2. It might ring some bells, right? The relationship between B and H is that B is inversely proportional to H. So what does this mean? Well, if you take the largest side of the triangle as the base, its corresponding height would be the smallest of all the three heights. Similarly, if you take the smallest side of the triangle as the base, the corresponding height would be the largest. Now the next formula we need to learn for calculating the area of a triangle is half into AB sine theta. Here, theta is the angle between sides A and B. This is something really important to keep in mind when you apply this formula, because if theta is not between the sides A and B, if theta is elsewhere, you cannot apply this formula. Let's move on to the next formula, which is area is equal to the square root of S into S minus A into S minus B into S minus C. This formula is called Heron's formula. Here S is a semi-perimeter and A, B, C are the three sides of the triangle. If you guys didn't know, semi-perimeter is equal to half of the perimeter of the triangle, which would be A plus B plus C divided by 2. In most of the questions, especially for CAT, the altitude of the triangle will rarely be given, and in those cases, this formula will be very useful. Now the next two formulas are quite interesting. I say they're interesting because these formulas are rarely used to calculate the area of a triangle. Here area is equal to R into S, where R is the inradius of the triangle and S is the semi-perimeter of the triangle. Now in most cases you will be using this formula not to find the area of the triangle but to find the inradius of the triangle. Let's just quickly solve a question to drive home this point. So in this triangle you see here, we have all three sides of the triangle. They are 3, 4 and 5. What we have to find is the inradius of the triangle. So the area can be found using Heron's formula, but many of you guys must be knowing that 3, 4 and 5 are a Pythagorean triplet. That is, they are sides of a right angled triangle. So the area of the right angled triangle can easily be found because 3 and 4 can be taken as the height and the base. We know inradius is equal to semi-perimeter divided by area. So first we find the area of the triangle using the formula half into base into height, which is half into 3 into 4, which is equal to 6. Now we know the semi-perimeter S is equal to 3 plus 4 plus 5 by 2, which is also equal to 6. So finally we have the inradius R is equal to 6 divided by 6, which is equal to 1. Now let's move on to the final formula, which is the area is equal to A into B into C divided by 4 into capital R, where R is the circumradius of the triangle. Now again students, if A, B and C are given to you, you can easily calculate the area using Heron's formula. So this formula A into B into C divided by 4R is always used to calculate the circumradius of the triangle. Now let's quickly solve a problem. So here we have a triangle of sides 12, 13 and 5. So let's solve a straightforward problem where we use all the formulas we just learned. And for this triangle, we have to find the area in radius, circumradius, and the longest altitude. Now let's use the Heron's formula to find the area of the triangle. The semi-perimeter would be 12 plus 13 plus 5 divided by 2, which is equal to 15. So substituting 15 into the formula here, we will get our area as square root of 15 into 2 into 3 into 10, which is the square root of 30 into 15 into 2, which is the square root of 30 square. It can be written as 30. So our final answer, the area is equal to 30 units. Now we have to calculate the inradius of the triangle. The formula for inradius is R is equal to area by semi-perimeter, which is equal to 30 divided by 15, which is equal to 2. So our final answer, the inradius is equal to 2. Next, we have to calculate the circumradius of the triangle. So if you remember, the relationship between area and circumradius is that A is equal to ABC divided by 4R. So this means that the circumradius R is equal to ABC divided by 4A. That is, R is equal to 12 into 13 into 5 divided by 4 into 30. So if we simplify this, we get the circumradius R is equal to 13 by 2. Now the next one is an interesting question. We have to find the longest altitude of the triangle. Now previously in the video, we learned that every triangle has 3 pairs of heights and bases. We also learned that the heights and bases are inversely proportional. This means that the longest altitude will be corresponding to the shortest base, the smallest base. So how do we use this information to find out the longest altitude? Well, from the previous calculation, we have found that the area is equal to 30. We also know that area is equal to half into base into height. That is, 30 is equal to half into base into height. Now remember students, to find the largest height, we have to take the smallest base. So let's take the smallest side 5 as the base here. Now, substituting these values, we can easily find the longest altitude of the triangle. We have 30 is equal to half into 5 into h. Now we should be able to get our final answer, h is equal to 12. For the next question, we have the largest side of a triangle is 50 units. Its area is 150 square units. If another side is 10 units, find the third side. So how do we solve this problem? Let's just start by drawing the figure, and we can try taking the base as 50. We know the area of the triangle is 150, so we can try finding the height of the triangle. We know area is equal to half into base into height. The base here is 50. So substituting these values, we get the height as 6 units. The question states that another side is 10 units. So let's take this side here as 10 units. Now that we've drawn the altitude of the triangle, we see that our triangle has been separated into 2 right angled triangles. Now we can calculate this portion of the base using the Pythagoras theorem. The length of the required side would be equal to square root of 10 square minus 6 square, which is equal to 8. Now that we know the length of one portion of the base is 8 units, we know the other portion has to be 50 minus 8, which is equal to 42 units. Now looking at the figure, it is fairly simple to calculate the third side of the triangle, the unknown side. The third side of the triangle is the hypotenuse of the triangle of sides 42 and 6. Again, using Pythagoras theorem, this time it's plus because we have to find the hypotenuse. It's square root of 42 square plus 6 square. Here we can take 6 square as common, and in the bracket we'll have 7 square plus 1. So the third side is 6 root 49 plus 1, 6 root 50, which is equal to 30 root 2. So the length of the third side is 30 root 2. Now let's go back and take a look at the question again. We see that it is mentioned the largest side of the triangle is 50. So 30 root 2 is less than 50, so our answer is correct. But what was the point of largest side? Why was largest side mentioned there? So when we solved the question, we took the base as 50. Now let's trying it by taking the base as 10. So let's take the other side as 50. Now again, to find the third side of this triangle, we first find the height of the triangle using the formula area is equal to half into base into height. So we have half into 10 into h is equal to 150. Now we found that h is equal to 30. Again, using Pythagoras theorem to find that portion of the base, which would be square root of 50 square minus 30 square, which is equal to 40. So how is the small portion of the base 40 units long when the entire base is only 10 units long? Why is that so? Can you guys think of a reason? Well, it is because the triangle is an obtuse triangle. Let me show you. So now you see why it was mentioned that 50 is the longer side of the triangle. Because when you draw the triangle with 10 as the base, 50 could either be on the left or the right side of the triangle. As you can see, I have marked the left side of the triangle as 50, and this is because the question has told me that the longest side of the triangle is 50. In fact guys, if I had marked the other side as 50, I would get a different solution to this question. So to ensure that everyone gets a unique answer, the people who made the question stated that 50 is the longest side of the triangle. Now let's quickly solve this question with 10 as the base. We have already calculated the height as 30. Again, remember guys, for obtuse triangles, the altitude will land outside of the base, okay? And remember, we calculated the base by using the right angle triangle with hypotenuse 50 and altitude 30. That would mean the entire base is 40. And this would mean that the remainder of the base shown in dotted lines is 30. 40 minus 10, 30. Now we have to find the third side of the triangle. So as always, let's use Pythagoras theorem, and we have square root of 30 square plus 30 square, which is equal to 30 root 2. As you can see, we have arrived at the same solution.